What does it mean when we say that an infinite geometric series converges? So here's an infinite series. Let's confirm that it is geometric. 1/3 divided by 1 is 1/3. 1/9 divided by 1/3 is 1/3. 127 divided by 1/9 is 1/3. So the common ratio is 1/3. And we know if the common ratio is less than 1, then the series is said to converge. But what does that mean? Let's take some partial sums and look at the actual numbers. So 1 plus 1/3 is 1.3 repeater. 1 plus 1/3 plus 1/9 is 1.4 repeated. The fourth partial sum gives us 1.481. And we're beginning to see a trend that is getting closer and closer to a particular number. Let's add another term. And you're beginning to see that it's getting closer and closer to 1.5. And that's what it means if it converges. It gets closer and closer to a particular number. So let's look at the formula. An infinite series converges, then its sum is a divided by 1 minus r. Well, a is equal to 1, and our common ratio is 1/3. So 1 divided by 1 minus 1/3 is 1 divided by 2/3, which is 3/2, which is 1.5. That's what we're expecting because we're noticing that every time we added another term, it got closer to 1.5. So what does it mean if an infinite geometric series diverges? Well, let's find the common ratio first. 3/2 divided by 1 is 3/2. 9/4 divided by 3/2 is 3/2. So the common ratio for this series is 3/2. And because it is greater than or equal to 1, this series diverges. So let's look at some partial sums and see what happens. 1 plus 3/2 is 2.5. We add the next term, we get 4.75. We add another term, we get 8.125. And another term, and another. You can see that the sums are not getting closer to a particular number. The sum is just getting bigger and bigger, and that means it diverges.